Hi, welcome to McMay's Research Educational Consults. Today's tutorial is on demand functions and comparative statics. I know this has been kind of trouble for a couple of us, and so once you've had the opportunity, we'd like to share what we've also gotten over. And then it would also be useful to our fellows in the master's class and that of the PhD class also. Okay then. So by way of introduction, we'll be taking you through the demand function, the comparative statics, and a little bit of conclusion. In that sense, the demand function will touch on the Walrasian demand correspondence, few assumptions underlying the correspondence, the comparative statics talk of the wealth effects, price effects, and their implications for the wealth and price effects also. So let's just jump into it. Now, in our previous videos, we expressed that the consumer's main decision is to maximize utility. Now, you can also understand the consumer's behavior by understanding the choices that they are making over time. So there are two approaches to understand the consumer's behavior. You can do that either through the preference-based approach or through the choice-based approach. If you want to understand the consumer through the preference-based approach, then we're going to hold some assumptions about the preferences that he makes. And then you make some assumptions about it, understand the choice that they make by analyzing the effects of these choices. Now, with the preference or the choice-based approach, we're going to make assumptions about the consumer's choice, and that is going to be the consistency. We are assuming certain consistency of the consumer's choice and its effects on the choices that they are making. Now, to just jump into it, we are saying that the Walrasian demand correspondence, which flows from the preference-based approach, suggests that for every price and wealth pair that is available to the consumer has the choice of making several bundles that would exhaust these budget constraints. The understanding is that given price and given wealth, the consumer has the ability or the choice of choosing from different bundles that would give him the same level of satisfaction. And that is the Walrasian demand correspondence, where a given budget set can afford different combinations or different budgets or different choice bundles that would give an amount of satisfaction to the consumer. Now, the reverse, it suggests that a consumer would only use a given price and wealth constraint on a specific bundle, suggesting that a given bundle as X in the face of price and wealth might either be used for several purposes or several bundles. Then we're talking about the multi-value, and that is the Walrasian demand correspondence. But when we assume that the consumer's budget constraint could only afford a given mix, a given bundle X, then that's a suggestion that the budget constraint has only one use, one purpose, to achieve that specific bundle, and that is called the demand function. So to help our analysis going forward, we are going to assume that this consumer has a demand function, suggesting that the budget constraint is able to afford a given bundle. Okay, so let's just continue from there. Just clean it up and then we continue. Yes, so now let's take some assumptions about the Walrasian demand function. Understand, we've moved from the Walrasian demand correspondence to Walrasian demand function. With the Walrasian demand function, there are certain assumptions that we need to hold. One is the homogeneity rule, suggesting that same changes in price and wealth, proportionate change in price and wealth, should lead to no change in the bundles. Okay, the understanding that if you are able to multiply through a function by a constant, and you are able to factor out the same constant without changing the function, then that function is said to be homogeneous of degree 0. You can look at this more from the Eugene Silberberg and Wenxian Structure of Economics, the Mathematical Approach 2020. This is from that. So alongside, I'll be making reference to certain literature and one of them, the core literature, is the Mascolel, and that of the Eugene Silberberg and then Wen Xiong, 2020. So with the homogeneity rule, it is saying that suppose this is the demand function and you multiply through a constant such that alpha price, alpha wealth, it should have no effect on the bundle that is going to be consumed. Let's look at it from here. Suppose this is the budget, and then we multiply or price increases by a given constant, and it's supported by same constant multiplication of the wealth. The effect is that the budget remains the same and is able to purchase the same quantity over time. So this X was initially bought by the wealth over the price. Suppose you multiply through the function by a constant, alpha W and alpha P. You realize that these alphas cancel out and we left with the same price and wealth, the same quantity that's going to be bought. So the understanding is that suppose you have a wealth of 10 cedis and the price of goods doubles and your wealth also doubles. The quantities you're able to buy doesn't change between yesterday and today. That's the understanding of the homogeneity rule, suggesting that when able to multiply through a function by a constant, when able to factor out the same, then that function is said to be homogeneous of degree 0. Now, that's an assumption that has to hold for the Walrasian demand function. Now, the second rule is the second part of the assumption that holds for the demand function, the Walrasian demand function, is that of the Walrasian law. The assumption suggests that we should have the situation where the consumer has to spend all his or her resources. Now, that is shown by this correspondence. You can see price times the demand function, which should be equal to the wealth, suggesting that there shouldn't be excess demand, no excess demand, such that whatever wealth the consumer has to be spent completely. Okay, so for any demand function, any choice bundle, which depends on price and wealth, we are saying that the total expenditure should be equal to the wealth. In that sense, we can see that any expenditure over wealth, a positive effect shouldn't exist. And so if we're saying that the consumer does not have excess demand, we are considering it at the point that it could either be a positive or a negative situation. So in either case, we don't want to see a positive excess demand, nor do we want to see a negative excess demand. Are we good? All right. So what happens is that should there be no excess demand, then the market is going to clear, and that is expressed by this summation function here, suggesting that the EI, which represents the excess demand. So the excess demand for given commodities, let's assume that the consumer has an amount of wealth to spend on 2 commodities. Now we are saying that his expenditure should be able to suffice all the 2 commodities, and there shouldn't be excess funds. In other sense, that would mean surplus demand. We don't want to see it. When that happens, then the demand function will cease to exhibit what we call the single value characteristic. That is what we want. Now think of it in this sense. Walras Law tries to achieve equilibrium, and he achieves it in this manner. Think of a market where we have city A. There's an excess demand for milk. Let's see city B. There has to be a surplus demand for milk, such that the excess demand in market A will be fed from the surplus demand from market C. In that sense, the market will clear. Think of that and bring it down to the household level for an individual. If you want to spend your wealth on different commodities, then should you spend and there is a reserve in one commodity, there should be a surplus for you to spend on the other. In that sense, it will end up exhausting all your wealth. So that is what Walras is saying, that this demand function should exhibit that characteristic. And so we are going to continue from there, having sufficed all the two assumptions. Now, let's try to understand the whole thing about the Walrasian law achieving single value, like I mentioned earlier on. So the whole expenditure, you can see from the matrix above, X1, P, and W suggests that the expenditure for commodity X1 can only be spent on X1. If you spend on X2, that should be it. You should finish with X2. And you can't spend both X1 and X2. When you do that, then you're talking about the multi-value. So you can express the Walrasian law in terms of these metrics. So each expenditure for each commodity or bundle